Hi there, let's learn programming. So in front of me here I have the program BlueJ, and BlueJ is what we're going to be using as our development environment for these early videos. Now the reason we're using BlueJ is that it's a great tool for beginners because it lets you visualize the components of your program very easily. As you can see, I have already a little rectangle here in this window titled main, which is a source file in our program and a class which we'll get into later. Now to follow along, you're going to need BlueJ, and you can download it from obviously the BlueJ website. I'll try and link it in the description. Or what you can do if you're on a Mac and you have Homebrew, and again, Homebrew is something you can download from the internet. Homebrew's got a website. You can do brew, cask, install, BlueJ. And if we just hit enter on that, it'll install BlueJ. Now, I already have it, of course, so it'll tell me that I have it, and it'll ask if I want to reinstall it. I can highly recommend using brew or Homebrew throughout this course, as it'll make getting the tools we'll need later on easier as well. But for now, all you need is BlueJ. And of course, if you're on Linux, you can use whatever package manager your operating system comes with, whether that be apt or yum or whatever. Let's go back to BlueJ. And let's look at this main class I have here. To create a new class, what you do is you click this new class button and you give it a name like main, like the one we already have on here. Now there's a bunch of other options here, and just ignore that for now and just make a class. I'll click into the one I've already made here, main. And normally there'll be a bunch of template stuff here that BlueJ makes for you. You can have a look at that if you want, but I've just cleaned it down to the core of it all to make it a bit easier to read what's going on in this tutorial. And the only thing we really need from it right now is this bit. Public class main, open curly bracket, closing curly bracket down here. Now the programming language we're using here is Java. And I think Java is a fine language to start out with. It's a fine language to continue with as well, of course. You can argue strengths and weaknesses for many languages, but really the most important thing is just getting started. And it doesn't matter so much what language it is. We'll easily transition to other languages once we get familiar with the core idea behind programming in general. So let's look at what we have here. The curly brackets define a scope, as we call it, which means that within these open and curly brackets here, we define what this main class is. Anything outside of these brackets does not belong to this scope, i.e. it's not part of the definition of the class main. So let's write something inside it. Let's say we want to create a method or a function, procedure, code, whatever you want. We'll just call it a method that will print a greeting to the user on the screen, just hello. Now, first what we'll do is we'll write the keyword static. We'll get into the meaning of that in the future, but for now just make it static. Then what you need in the beginning of a function is its return type. This is because some functions can do something and then return a value to where it was called from. But for this function, we'll just use the return type void, which means we don't need to return anything because it's just going to print the greeting and that's it. It doesn't need to give an answer back. Now we need to name the function. Let's name it hello. Then what we need is the parameters for the function. This is what input the function takes. If the user can give it something that it'll use in its operations. But we're just going to tell it that it doesn't take any parameters, which is leaving it empty. So just open parenthesis, closing parenthesis, nothing in there. And then, just like with the scope of the class, we make an open curly bracket, and then we close it down here. Now anything inside these curly brackets here is part of the definition of this method. So what do we want it to do? We want it to print hello to the screen. To do that in Java, we go system.out.print hello. Now to explain what happens here a bit. System is sort of the Java class we'll call to interact with the, well, system. .out is to get sort of the output portion of it, and print is the method or function that we'll use to, well, print to the screen. And just like I said about our own function here, method, taking parameters inside the parentheses in the definition of the function, print takes an input, which is what you want to print to the screen. So we'll open the parenthesis and we'll write hello in it. And we'll put it in these double quotes to indicate that it's not something in our program called hello we're giving as an input. It's the actual word hello, the string, the text. And then we'll close the parenthesis and put a semicolon. In Java, all operations end with the semicolon. So that's it. Let's now go back to our overview. And you can see that it's sort of like got these gray lines in the rectangle. It means it's not compiled yet. So we'll hit compile. This will sort of take the code we've written and translate it into something that the computer can run. So now we right click again. And you can see we got our method here, void hello. So let's click it. And it prints hello. Hey, we made a program. Now let's say we want to do a bit more. So we'll go back to our code and say that instead of just saying hello, we want the program to now say hello to the specific user using it. i.e. you can enter a name into it and it'll say hello to you specifically. So to do that, as you can imagine, we'll need to make this function have an input. To do that, what you'll need to do is you'll say, what's the type of the input? Because is it a number, or is it a letter, or a series of letters like text, or is it a truth value? Could be anything. So we need to tell the program what kind of input we expect it to have. And the type of input that we need for text is called string. A string in programming is generally just text. And then we name the input. So let's call it name because we're asking the user for their name. With that information, we can put a space after hello and say we want to not just print hello, but we want to print hello space plus name. And that's it. Now if we go back to our overview and we recompile this, again right click it to bring up this menu. And then we click again, right click, and get this menu where we can see our function. We can now see that it says that it takes string and name. Click it. And we can input whatever we want the name to be. So double quotes around it and say Casper, that's my name. And now the program comes up again and it says, hello Casper. As you can see, the beginning here, it still has our last program here. That's because it hasn't been cleared. We can clear this out and run it again. With my name again. And it'll now just say hello Casper. Another thing you can do is instead of using the print function, we can use the println. This means that instead of just writing it out, it writes it out and then it breaks for a new line. So if we run this again, compile, run, let's say hello Joe. Then it'll say hello Joe. Again, the hello Casper bit is from the last program, not this one. go back to the overview and say again, and then say Jimmy. Now it'll actually come up on 2 separate lines. So it'll say hello Joe, new line, hello Jimmy. So that's a basic hello program that will just greet the user. Java, however, is built around this idea of object-oriented programming. So we need to talk about what an object is. Obviously, we have types here like string, which allows us to pass a name, which is, again, a string. But we can make our own types. So we don't need to just have string. In fact, this class main here is sort of a type in and of itself. In this bit here, it's sort of like an empty type. It doesn't really have anything to offer, basically. But it becomes a type when we make it a class. So let's make a person type. Go back to our overview. We'll hit new class. We'll call it person. As you can see, we get a new little rectangle here in our overview. And if you double click that, it'll bring up the editor for it. Now again, this is what I said about there being a lot of template stuff when you create a new class in BlueJ. And you can, as I said, read it and get a feel for what sort of things can be in a class. But just to make it a bit easier to follow along with, I'll sort of wipe it clean. So we can go more from the beginning of it all. Remove all this. And remove all this. Oh, and that as well. Now, we have a person here. So now we need to define what's in a person. What makes a person? Well, like before, I'm sure we can agree that a person has a name. And we'll use something now called an access modifier. And you've already sort of seen this because right here it says public. And of course, it wouldn't mark that the way I intended. There we go, public. And that's actually an access modifier. We'll go into specifically what they're used for later, but it's sort of a form of controlling the scope of the code again. But let's say that these variables are private. And actually, I want to indent that. There we go. Private. So a person, as we said, has a name, which we've already discussed is a string name. And what else does a person have? Well, let's say that a person has an age, right? So again, we say it's private, just because we're going to do that for now. And what's an age? Well, an age is a number. What type would a number be? Well, we've got something called an integer, and in this case, we'll shorten that to int. That's sort of the keyword we use for that. Int is a primitive type, and we'll get into the meaning of that again a bit later. But int, that's a whole number, and we'll call it age. So again, you can sort of see the pattern here. We got the access modifier, which again we'll talk about in a future video. We got the type, and then the name. And this is generally how we're going to use all our variables. And again, ending with a semicolon. Let's add one more. Let's say we want a social security number. And again, that will just be of type int. So SSN, social security number. Now, what kind of operations would we want a person object to be able to perform for us? Well, maybe we want to be able to ask the question, how old are you? And for that, we'll say it's a public method. This is a public method called getAge, if I can spell properly. And what that'll do is it will return the age variable. And I forgot something, which is great. Always good to do that live code example stuff. Of course, forgot the return type. We need to specify what this method returns, and of course it returns an int because that's what the age variable is. So that's what I was talking about with respect to return types. This is a function that gives back a result. The result is of type integer. As you can see, we specify that with this return keyword, followed by what it is we want to give back. In this case it's age, which is this variable, which is an int. As you can see, these things match up. But in addition to all of this, we also need something else, because we specified that a person consists of a name, an age, and a social security number. But how do we make a person? Well, that's sort of where we get to the idea of a constructor. A constructor works similarly to functions like, well, what we just did here, the getAge function, except instead of returning some inner type like the int or some other type, what the constructor will return is a object of the type we're making. And in this case, we're making a person. So to specify that, we name it, or we set the return type to the same thing as the class is called, in this case person, and we don't specify a name of it. It's just the constructor. That's what it is. It returns a person. It is person. That's all it is. We still have a list of parameters because maybe you can't construct a person without being told their name. So let's say that to create a person, we need a string, which is the name. We need an int, which is their age. And we need an int, which is the social security number. We need all of these things given. We can't just make them up on the fly. In some cases, you might not create a field, as it's called, or you might not need a parameter for the constructor for every field, as it's called. Let's say that the social security number was something we were just going to generate automatically given a name and an age. Well, you wouldn't need to have that here for the creation of the object. You could just make it up in here. So now we have this constructor with 3 parameters corresponding to our 3 fields: the name, the age, and the social security number. And inside here, to assign it to the 3 fields we have here, we're going to say this, which is the object we're inside, the person we're creating, dot name equals name. So again, this dot name refers to this here, the string name. And when we just write name, we're referring to this one because it's the closest scope, right? We're always picking the one that's the closest to us, if you can think of it that way, unless we specify something else. And we're just going to do this for our 3 variables. So again, this dot age equals age, and this dot ssn equals ssn. So now we've told BlueJ, or Java if you will, how to make a person and something you can do with a person. Okay, that's great. Let's go back. And inside our main method here, or our main class, sorry, instead of asking for the string for a name now, we'll instead ask for a person. I would just call it P. And instead of saying that we'll do a name here, which you can see is now red, that's not allowed because we don't have a name. We're going to go P dot get name, because we're going into the P object, dot for going into it, and using the function in there we just defined called get name. Right, so far so good. let's go back to our overview and try and test this. We'll do this. And looks like something's wrong. What did I mess up? And that was of course me being completely silly, because the function we made inside of the person object here was called getAge, when of course what we wanted was a function string called getName, which returns the name. That's what we wanted. My bad. Now it compiles. Great. So what we'll need is to create a person. So I'll right click on the person and I'll click new person. And it'll ask me to instantiate this. Alright. So say the new person will be with the name Jimmy. He'll have the age of 27, and he'll have a social security number of just some random shit. Right? And now in our hello function, we can give person 1. If you can see, Jimmy is called person 1 down here in the objects catalog. Right? We'll click OK. And we'll bring up the terminal. And as you can see, it correctly says hello Jimmy, because that's the name we gave to the person object. And that's sort of the fundamental idea behind object-oriented programming. Is that we structure things in these objects that sort of correspond in a way to the real life things. If you want to represent a person, well, you represent a person in code by creating a class for them and making objects of that class that we then operate on. It's a sort of nifty little way of structuring your code in a way. So that's it for this one. Thank you very much for watching, and I hope you learned something and that you found it fun. Don't worry about it at all if you didn't understand some or even all of this, because there are a lot of topics in programming and we're only just scratching the surface. We're going to dig way deeper into all of the things we've covered today, and hopefully that'll clear things up and make it easier to follow them all. This was more just to get something going that we can run and try out. The more code you write, the better, really. So just experiment with what you've seen and try and make your own classes and return field variables. Try and do things like that. Experiment around, and I'll see you in the next video, where I think we're going to look at the different types, different built-in types and the type system. Maybe we'll even look at inheritance, which is a topic from object-oriented programming. And it's going to be great. We're going to have a lot of fun and dig into things. So see you in the next one.